Okay, I'm going to give you some numbers here, and you know, one way or another, you're going to have to trust what I say, or else, you know, your conclusion is I'm the biggest liar on the planet. But anyway, this battery started at 12.79. This battery started at 12.87. I got some batteries here in parallel in my battery 3 position. They start at 12.67. When you have batteries in parallel, they tend to balance out. So all of them, as long as they're connected, are going to read 12.67. I've got a little boost converter here. It's not a highly efficient one, but it's okay. Here's a less efficient one, and you can see the difference between the toroids. This one has more windings. This boost converter is a little more efficient. I've got a really efficient boost converter here, but it will not work on this setup because there is a chip on here, and it doesn't like the wiring configuration we need to use to run these boost converters. So anyway, the way this works is the positive from this battery goes to the positive in on the boost converter. Let's move these two out of the way. The negative in on this boost converter goes to the positive over here on battery 3. The positive out from the boost converter goes into one side of my 12 volt Razor scooter motor, which I got sitting here in the vise, and the other side of my 12 volt Razor scooter motor also goes over to battery 3. So that's the configuration. When I start it up, you're going to see that the motor's going to start running as soon as I touch this, but it won't be until I hook that negative over onto battery 3 that it really gets the power that you want it to have. So here we go. It's going to start. It should start. Negative in. Sometimes I got to give this little motor a little turn. There it goes. Because Matt's motor has some places on it where there's a dead spot, so you got to turn it sometimes. Output of the motor is going up here, so that's right. The only thing I don't have is here's that negative I was talking about, the boost converter. Now the negative in and the negative out are a through connection, so it doesn't matter which one you hook your negative wire to, but it does matter that you need to take it over here and hook at the battery 3 to get the power output, and you'll hear the motor speed up when I do that. Okay, there it's running. I'm not going to let it run for more than a second or two because I want to show you some stuff, and if I let it run too long, I'm going to throw off all my numbers. So here we go. All right, now we said this started at 12.79. I ran it for about 15 minutes earlier, and oops. This voltmeter where I can hook it to all 3 batteries at the same time. So here we go with this this battery, and the meter is showing 12.6. We started with 12.79, so that's a loss of 0.19 volts. This one started at 12.87. It is at 12.7. So that's a loss of 0.17 volts. So 0.16 or 0.19 and 0.17. Let's just round that off to say we lost 4 tenths. 4 tenths. 4 tenths of a volt. Okay. Over here, we started at 12.67, and now we're up to 12.8. 12.67 to 12.8, which is 0.13 volts. Let's just round that off to 1 tenth. So we lost 4 tenths, we gained 1 tenth. The difference is we gained 1 tenth on 12 batteries, okay? And we ran the motor for free. So we lost 4 tenths, we gained over 1 tenth on 12 different batteries, and we ran the motor for free. And that's the kind of system that we're talking about here.